Alright, you are welcome again. How are you doing? And how is everything? Okay, let's see what we have for today. We're going to treat formation of number system. Formation of number system. Please, it's a kind of theory and it's going to be long. Please, I want you to pay attention and get what you needed to get here. This is the first topic under Math 112. That is formation of number system. Okay, now let's go. In counting, the first set of numbers that was used for counting is 1, 2, 3, 4, 5, 6, 7, 8, 9. You get it? Good. These numbers, they are called natural numbers. They are called natural numbers. Then the natural number, it continues. You get it? That is from 1, 2, 3, 4 upwards. That is natural numbers. Now, the definition of natural number is this. We say the set of numbers denoted n such that the numbers are 1, 2, 3, 4, 5, 6, etc. is called natural numbers. You discover that these natural numbers include even numbers. And then when I talk about even number, I hope you understand, right? Even numbers are talking about numbers that are divisible by 2. It also includes odd numbers. Odd numbers are numbers that are not divisible by 2. More also, it includes prime numbers. Then when I talk about prime numbers, they are talking about numbers that is only divisible by 1 and itself. Numbers that are only divisible by 1 and itself, they are called prime numbers. Example, 3, 5, 7, 11. You get it? 17, 19, etc. They are called prime numbers. There is no other number that can divide it except 1 and itself. Okay, we'll just talk about natural numbers, alright? Good. Now, this set of numbers were used for counting. But along the line, there was a problem. And then this problem is something like this. Something like 5 plus x is equal to 5. And then you discover that what is the number from the natural numbers, from the set of natural numbers that you can pick and replace this x and it will give you 5. You discover that, okay, let's just say if you pick 1, when we say 5 plus 1, it will be 6. No. If you pick 2, it will give us 7. If you pick 3, 8. That means there's no number from the natural number that can solve this problem. You get it? Okay, let me just show you for an instance. A man that is selling cow. He has something like 5 cows. And he sold 5 of them in a day. And then somebody asks a question and say, how many cows does this man have? Definitely he has cows. Or he have cow. The number of cow that this man has is 0 cow. And then this 0 cow it cannot be found from the natural numbers. So for this problem to be solved, 0 was introduced to the natural numbers. So as 0 is introduced, it is now called whole numbers. That is, 0 is now introduced to the natural number. That is to say that you now have 0, 1, 2, 3, 4 upwards. Okay? Now let's see the definition. The definition say, the set of numbers formed by adding 0 to the set of natural numbers denoted by W. For instance, 0, 1, 2, 3, 4, etc. is called whole numbers. You get it? Good. We have just graduated from natural number and then formed another set of number system called whole number. And how was this done? It was formed by introducing 0 to natural numbers. And then because of the 0 that is being introduced to this natural number, it is now called whole numbers. Okay? Alright. At this period, natural number and whole numbers were used for counting until a problem showcased. And then this problem says something like this: 5 plus x is equal to 2. 5 plus x is equal to 2. And we said, okay, from the set of whole numbers, what is the number that we can pick and replace it with this x that it will qualify or it will make this statement to be true? So if we solve this, what is it going to give us? We discover that there is no number that we can find from the whole numbers that will satisfy this expression. There is no number. You get it? So, okay, let's just say if you pick 0, if you say 5 plus 0, it will give you 5, not 2. Okay, if you pick 1, 5 plus 1 is 6. So, all the numbers in the whole number, none can satisfy this problem. And then we discover that there is a need to add another set of numbers. And then the set of numbers, this set of numbers is called directed numbers. These are numbers opposite, direct opposite to the word natural numbers. You understand? That is, in whole numbers we have 0, 1, 2, 3, 4 upwards, right? Now this one is direct opposite. Instead of going from 0, 1, 2, 3, you go backwards: 0, minus 1, minus 2, minus 3. So you can say that this is the invention of negative numbers. So negative numbers were introduced. So as these numbers were introduced to the whole numbers, it is now called integers. Hello. It is now called integers. And so what is integers? You would just say that integers is the set of directed numbers denoted by z. Example: z is equal to 0 plus and minus 1 plus and minus 2 plus and minus 3 plus and minus 4 plus and minus 5, etc. You get it? That is introduction of negative numbers. Then in the right hand side you have positive. In the left hand side you have negative. And then in the center you have 0. The right hand side is equal to the left hand side. So you discover that with the introduction of these negative numbers, the above problem can be solved. So if you want, okay, let's just say you want to solve this problem. You can simply say x is equal to 2. You bring 5 to the other side, to be 2 minus 5. It will give you minus 3. So minus 3 is found in this new set of numbers. You understand? Okay, let's go. Now we have formed 3 more number system. Okay, the number system that we have now are, we have natural number, we have whole number, and then we have integer. And then integer is the set of numbers formed by introducing negative numbers to the whole number system. You get it? So as of this point, integers are used for counting until a problem came up. And then this problem has no solution in the integer. Then this solution is like this. 3x is equal to 2. If you solve this problem, or you want to check from the integer what number can satisfy this expression, you discover that you cannot. There is no number. You cannot find any. So what are we going to do? So because of this problem, we now realize that there can actually be numbers in between whole numbers. I don't think you understand what I'm saying. That is to say, there can actually be numbers in between two numbers. For instance, 1, 2. That is to say, as you count 1, before you count 2, there should be numbers in between. For instance, there should be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then 2. You get it? Okay. So, because of this, there were another set of numbers that were introduced. And then this number were called, or is called, common fractions. This numbers is called common fractions. Okay, for instance, let's solve the question. We have 3x is equal to 2. If you want to solve the divide both sides by 3. So, you have x is equal to 2 divided by 3. So, 2 divided by 3 is exactly 0.6666. Continue. You get it? So, approximately you have 0.6. Okay, approximately, let's say 0.7. Then you discover that as you count 1, there is a number, or there are numbers in between before you can count 1. So this number is 0 point. Other things. You get it? So this number 0.7 is found in between 0 and 1. So the introduction of these common fractions to integers, we now name these common fractions rational numbers. We name these common fractions what? Rational numbers. So the definition of rational number is this. We say that the set of numbers formed by adding common fractions to the set of integers is called rational numbers. It is denoted Q by the letter Q. And then you say Q is equal to X such that this colon, let me just read this statement. This statement says Q is a set of numbers X such that X is equal to P all over Q. That is, X is a number in form of P all over Q. That is, X is a kind of a number that looks like P all over Q. And then that Q is not equal to 0. And then P, Q are what? Integers. P and Q, they are integers. And you understand what we mean by integers, right? Good. So we have formed another set of number system, and then this number system is called rational numbers. Okay, these rational numbers can be represented in decimal numbers. Rational numbers can be represented in decimal numbers, e.g. 1 all over 2 is the same thing as 0.5. You get it? 1 all over 3 is the same thing as 0.3. So you discover that 1 all over 2 is a common fraction, and then you can represent it in decimal number. And then decimal number is talking about the point, or the number having point, just like 0.5, 0.33. Okay? You get it? So we say that rational numbers can be represented in decimal numbers, and we saw example, right? Good. Let's continue. Rational numbers has two forms of decimals. I told you that rational numbers can be represented in decimal, and then in that decimal can be of two forms. Please don't be confused. Let me come again. Rational numbers can be represented in decimals. Okay? And then in representing them in decimals, you can represent it in two forms of decimals. In two forms of what? Decimals. For instance, number one form is terminating decimals. Number one form is what? Terminating decimals. What does it mean by terminating decimals? That is, when you have something like 1 all over 3. Okay? 1 all over 3. What will it give you? It will give you 0.3. Okay, now, no. Let's use another example. 1 all over 5. Sorry, 1 all over 2. Okay? If we use 1 all over 2, what will it give us? It will give us exactly 0.5. You get it? It will give us 0.5. Okay? If we use 2, if we use 2 all over 5, it will give us 0.4. 2 all over 5. It will give us 0.4. Now, terminating decimals are decimals that are not continuous. You get it? That are not what? Continuous. They get to a point where it stops. You know, in those days when we are solving long division, they will tell us that You continue to be going, you continue to be solving, oh, to eternity or to your book finish. You get it? So it doesn't have where it stops. That is non-terminating. But this rational number, it terminates. You get what I'm saying? Number one form is that it terminates. That is, it gets to a point where it stops. And it will not be far. That your calculator cannot contain it. It can be 2 decimal places, 3 decimal places, 4. You understand what I'm saying? Good. Another form is non-terminating but repeating in blocks. Another form is non-terminating but repeating in blocks. For instance, 1 all over 3. 1 all over 3 is not terminating. It's continuous. And it is repeating himself. 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. That is repeating in blocks. You get it? Good. Now, let me show you example of this non-terminating but repeating in blocks. We have 0.2727272727 continuously. 2727 is what? Repeating in blocks. It can be repeating in blocks in 1 decimal, in 2 decimal, or in 3 decimal. You understand what I'm saying? Good. Now let me give you another example. We have 2.545454545454 continuously. It is repeating. You get it? Good. Now let me show you. There are sometimes you may have 3. You may have a number like this. Let's say 2.7182. You get it? 81825. You get it? Now let's take this one. This one say 2.7182818225. It seems as if it wants to repeat, but it's not repeating. Be careful with repeating in blocks. Alright? So let me show you as another example. We have minus 0.666666666 continuously. So what we are saying here is this. Rational numbers has 2 forms of decimals. Number 1 form is terminating. It terminates. It's not continuous. And then number 2 is continuous but repeating in blocks. And then I told you what repeating in blocks simply means. You understand? The numbers are repeating themselves. It can be 2, 2. It can be 3, 3. You get it? It can be 1. But it's repeating himself. You get it? That is it. Okay. You discover that this number system at this point in time is being used. But there's still a problem that has no solution in rational number. There's still a problem that has no solution. Oh my God. Okay, let's see the problem. The problem says x squared is equal to 3. X squared is equal to 3. So please get your calculator and punch this. So if you want to solve something like this, you are going to take the square root of both sides. You get what I'm saying? Take the square root of both sides. Then we'll have square root of x squared and then square root of 3. So this square, we cancel the square root. You get it? Then we'll have x is equal to square root of 3. So now, punch your calculator, square root of 3. Square root of 3 will give us 1.7 1.7320508088. Wow. He gave us what? 1.7320508088. You discover that such number like this, a number like this, is not found in rational number, because in rational number is either terminating or continuous and repeating in blocks. But this one is continuous and is not what? Is not repeating in blocks. It's continuous and is not repeating in blocks. So how are we going to do it? So we introduce another set of numbers that are not rational, which are the numbers that are continuous. That is, they are non-terminating and non-repeating in blocks. Non-terminating and non-repeating in blocks. And then we call this set of number what? Irrational numbers. We call it what? Irrational numbers. You get it? So you discover that we had a number called a rational number system, okay? Now, we introduce another set of number that are not what? Rational. We call them what? Irrational. Alright? Now, when you combine rational number and irrational number, it gives you another set of number system that we called real numbers. That we called what? Real numbers. Now, let me show you the definition. The set of numbers formed by adding irrational numbers to rational numbers is called real numbers. You get it? The set of numbers formed by adding irrational number to the set of rational numbers is called real numbers. Okay? Are you getting what I'm saying? Good. Now let's go. What is irrational number? The definition. So the definition of irrational number, I say that the set of real numbers that are not rational is called irrational numbers. You know, I told you that real numbers is a combination of rational number and what? Irrational number. And then this set of real numbers that are not rational, we call them what? Irrational numbers. Now let's see difference between rational number and irrational numbers. We have major difference. Let me show you. Number one, rational numbers are terminating decimals. Number one, rational numbers are what? Terminating decimal. They terminate. And then number two, rational numbers are also non-terminating but repeating in blocks. But irrational numbers are non-terminating and also not repeating in blocks. You get what I'm saying? I say, let me come again. The difference between rational number and irrational number is this. Number one, rational numbers are terminating decimals. Irrational numbers is what? Are not terminating what? Decimals. Number two, rational numbers are also non-terminating but repeating in blocks. Why irrational numbers are non-terminating and non-repeating in blocks? Please, hope you are clear, right? Good. Alright. I still have a tutorial that I'm going to produce, that is properties of irrational number. In that tutorial, we are going to learn properly. Anywhere you see irrational number, you don't need to think twice before you can detect. Alright, so that is the next tutorial we're going to have. The properties, some of the properties of irrational number, so that you can easily detect or differentiate between a rational and irrational number. Alright, good, let's go. Now, We have formed several number system. We started from natural number, then we formed another number called whole number. From whole number we formed integers. From integers we formed what? Rational numbers. From rational number we formed irrational number. From irrational number we formed real numbers. Now, this real number is where we stop, or where we can stop for now for elementary calculus. But I don't want to stop here. I want to go extra. So, we are using these real numbers for counting. But there is still a problem that this real number cannot solve. That a solution is not found in real number. Should I show you? Okay, let's go. Please help me and find the square root of minus 4. The square root of what? Minus 4. That is, what is, when they're talking about square root, they're talking about a number that can multiply itself and give you a particular number. Alright? Good. Now, square root of minus 4 is talking about what is the number that will multiply itself and it will give you minus 4. Okay, you want to say 2? 2 times 2. It will give you what? 4. You cannot say 2 times minus 2. It's not possible. We are talking about a number that will multiply itself. 2 is different from minus 2. Hope you get what I'm saying. Good. So you discover that there is no number in real numbers that can solve this problem. Hello? Oh, wow. So the square root of minus 4 is not found in real number system. Now let me show you something. To solve this problem, we split this number into 2. The first one we give you square root of 4 times square root of minus 1. Square root of 4 times square root of minus 1. So that when you say square root of 4 times square root of minus 1, it will give you square root of what? Minus 4. Is that clear? Good. Now, square root of 4 is what? 2. Abi? Yes. Okay. Square root of minus 1 is nowhere to be found. Nowhere to be found. No. Nowhere to be found. So we said, since this square root of minus 1 is nowhere to be found, we can actually call this number imaginary number. A number you just imagine that it exists. We call it what? Imaginary number. Okay, imaginary. We choose the letter what? I from imaginary. And then say that square root of minus 1 should be called imaginary number. And then we use the letter I to represent it. And then you can simply say square root of minus 1 is equal to I. Hello. This is mathematics for you. So, you discover that we have just found a solution to this problem. So, by calling it imaginary number. So, the set of numbers that is formed by adding imaginary numbers to the set of real numbers is called complex number. Hello. All right, I hope you are following. I know you may have a question, but time will permit us. You throw your question to my email. All right, let me come again. You see, the set of numbers formed by adding imaginary numbers to the set of real numbers is called complex numbers. Please, this complex number system, it doesn't end here. There's still other problems, and but for your level now, let's stop for here. Okay, thank you very much. Thank you. Okay, in mass 1-1 1, we are going to talk about complex number. That is where we will treat more on this case. Okay, so don't worry, we are going to treat much on complex number. So our next tutorial, we're going to talk about some properties of irrational number and then properties of real number. Please, these two tutorial is very, very important. Please don't miss it. Okay, thank you very much. Thank you for watching. Yes, this our tutorial has been authorized by the School Student Union Government, which is SUG. So as you are watching, feel relaxed. It is authorized. All right, thank you very much. Keep watching. If you have not subscribed, please subscribe.